Welcome to episode 70 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I am Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Imagine if, instead of spending weeks or months building AI models, you simply handed that task over to a machine. Today, we'll dive into AutoML, letting machines build models.
That's right, Jonas. AutoML sounds like a bit of magic, especially for folks who aren't data scientists. But it's very real and very practical, a game changer for businesses wanting to get AI projects off the ground faster without the heavy lift.
Let's start with the basics. AutoML stands for Automated Machine Learning. It's a set of tools and techniques designed to automate many of the repetitive and time-consuming steps in creating machine learning models.
And those steps are usually quite detailed, right? Like choosing the right model type, tuning all the settings, picking which data features to use, all stuff that usually needs a skilled data scientist.
Exactly. Traditionally, an expert must guide the entire process, pre-processing data, selecting algorithms, training, validating, and fine-tuning parameters. AutoML systems encapsulate this knowledge and automate it. Think of it as having a junior data scientist who never takes a coffee break.
A tireless junior analyst, I like that. But let's bring this closer to real business. For example, in retail, I've seen AutoML help companies predict product demand across thousands of SKUs. Instead of hiring a big team of data scientists to build custom models for each product, AutoML tools handled it with a few clicks.
That's a great illustration. Automation through AutoML targets efficiency and scalability. The big motivation is to make building models accessible and repeatable at scale.
Though it isn't just about speed, I've noticed it helps prevent human bias and error too. Sometimes experts get stuck in their favorite approaches or overlook simpler or alternative models. AutoML tests a large variety of options we might miss.
True. To put it simply, AutoML explores and experiments systematically. It runs through multiple algorithms like decision trees, support vector machines, or neural networks, and picks what performs best on the data and problem at hand.
And it's not just picking models. Some AutoML platforms handle feature engineering too. That's the process where raw data is transformed or combined meaningfully before feeding into a model.
Feature engineering often requires domain expertise and creativity. Automating it means AutoML tools can try many mathematical transformations or combinations automatically, potentially uncovering hidden signals in the data.
That's crucial in industries like healthcare. I remember consulting for a hospital system that wanted to predict patient readmissions. They were drowning in data but had limited data science staff. AutoML helped sift through vast clinical data, lab results, and demographics, building predictive models that identified patients at risk.
From the theoretical side, AutoML frameworks typically include three core components: data preprocessing, model selection, and hyperparameter optimization. Hyperparameters are the knobs you turn, like deciding how deep a tree should grow or the learning rate in neural networks.
Changing those knobs can radically change model performance, but searching for the right combination manually is painful and slow. AutoML's automated search can be literal trial and error at scale, guided by smart algorithms.
Methods such as grid search, random search, and more advanced techniques like Bayesian optimization or evolutionary algorithms help AutoML efficiently navigate this hyperparameter space.
From the field perspective, I've seen companies adapt AutoML to lower the barrier to experimentation. For example, a finance firm used AutoML to test credit risk models on different customer segments quickly, without waiting months for specialists.
That's a good point. AutoML isn't meant to replace data scientists, but to empower analysts and managers to prototype rapidly and broaden the AI adoption horizon.
And that's where it gets interesting. Some skeptics say AutoML models are like black boxes and can be less interpretable or reliable compared to handcrafted ones.
Interpretability is a valid concern, However, many AutoML tools integrate model explainability features like SHAP values or feature importance rankings to help understand why certain predictions happen.
Yes, though we have to be careful. AutoML might generate complex ensemble models or stacked learners that perform well but are trickier to explain to non-technical stakeholders.
Ultimately, businesses must balance accuracy, interpretability, and compliance, especially in regulated industries.
Speaking of regulation, in healthcare or finance, automation needs guardrails. AutoML platforms often include validation checks and fairness constraints to mitigate bias or avoid overfitting.
And overfitting, where a model memorizes training data instead of generalizing, is a classic machine learning pitfall that AutoML addresses through cross-validation, repeatedly testing models on different data splits.
Stepping back, what industries are really benefiting from AutoML right now?
We've touched on retail demand forecasting and healthcare risk prediction. AutoML is also strong in manufacturing, optimizing quality control and predictive maintenance.
In automotive, for instance, one of my clients used AutoML to accelerate defect detection in parts inspection. Their traditional models took months to tune. AutoML cut that to weeks, saving millions in recalls.
And in marketing, AutoML helps personalize customer experiences, like building churn prediction models that guide targeted retention campaigns.
Also, in small to medium businesses, AutoML democratizes AI. They can leverage cloud-based tools without hiring extensive teams, allowing startups and niche players to compete.
But it's important for organizations to invest in good quality data and domain knowledge. AutoML can automate modeling, but feeding it messy or biased data leads to poor outcomes.
Absolutely. Garbage in, garbage out still applies. Plus, monitoring models over time is critical. Business conditions change, and AutoML solutions must be rerun or retrained regularly.
To summarize the benefits, AutoML boosts efficiency, reduces reliance on expert scarcity, standardizes processes, and accelerates innovation.
And from my side, it enables rapid experimentation, wider AI accessibility, cost savings, and sometimes uncovers insights that human experts might miss.
But we should also note the challenges: interpretability, data quality, and the need for ongoing governance.
In practice, I recommend companies view AutoML as a powerful assistant, not a complete replacement, combining it with human insight for best results.
Well said. As AI matures, AutoML serves as a bridge between complex modeling and business pragmatism.
So, our key takeaway?
AutoML automates many time-intensive steps in machine learning, enabling faster, more scalable, and often better quality models.
And from my side, AutoML empowers businesses to experiment and deploy AI quickly, but needs thoughtful data management and interpretation to make real impact.
Next time, we'll take a broader look at the landscape of data tools, a checkpoint to make sense of the technologies shaping AI today.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your comments or questions. They might just appear in future episodes. Until tomorrow, stay curious, stay data-driven.